Okay, so in chapter 7, this is one of the favorite chapters and also one of the easiest chapter to actually score. And this is where the fun element comes, where you use the Proteus to do a lot of interfacing between switches and also LEDs. So you can see some animation going on and you get excited. So chapter 7 is entitled Parallel Input Output Ports. And here is a diagram of a PIC-18. So PIC-18 have several ports. So remember the PIC-18, for those who missed the first class, introduction class, it has pins. So let's see if we can get Google to show us. Okay, let's see, we have PIC-18F. So this is one example of PIC-18. Do you see all these pins, the legs? So those are the input, parallel input output pins. Now those pins are grouped in ports. They are port A, port B, port C, port D, port E. Depending on the number of pins that a particular microcontroller has, it has that many ports. Now because this is a 8-bit microcontroller, you will see that the maximum bit that a port can have is 8 bits, which means 1 bit for every pin. So how do you see how many ports do you have? Do you see this term even to the website? Do you see it's mentioned RD, then you see RC, it's RD, there's RB, there's RA, RC, RD, RC, RC. So all those are actually denoting the ports. If it's RC means it belongs to port C. And the number 0, RC0, RC1, RC2 means the pin number of that particular port. So you can have as many ports as a particular microcontroller can. So let's go back here. So those pins are our interfacing pins where we can connect to an input pin, which is like a switch, or we can connect it to an output component like an LED. So it is known as parallel input output, which means you can configure every single pin to be either input or output. So you need to configure. So all those are digital input output pins. So here as an example, we have a PIC-18 and I have drawn this blue box. The blue box is actually known as data register, and the data register has a special name, port X. X stands for what's the port name. So let's say if we are having RD, that means this is port. What port is this? So this is port D. So this will be port D. So every single port is actually nothing but data register. So one data register can hold how many bits? 8. And therefore it has 8 pins. So these data registers are connected to the pins. So therefore you see there's RD0, RD1, RD2, RD3, RD4, RD5, RD6, RD7. Is that okay? For every bit of the data register, it corresponds with a particular pin of that port. Are you okay up to this point? So let's say if we want to connect the particular pin, do you know what symbol is this? It's an LED. So we connect the pins to a 330 ohm and connect to LED and connect to the ground. So when I put dot 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 like this means all the pins are connected to LED. Are you all following? So port D pins. Of course, PIC 18 not only have 8 pins, there are so many pins. I'm just focusing on port D. One of the things that will be tested in your test 2 is this kind of drawing. You need to know how to draw simple schematic. Now the first thing that you need to do is configure the data direction register. So the data direction register is known as TRIS-X. It's another special function register. So in this case, because we are using port D, so for this, every data register or every port has its own data direction register. So if we are dealing with port D, this will be TRIS D. It will be TRIS D. So if you TRIS D is a special function register, port D is our data register. Now this register is known as data direction register, which means through this TRIS register is where we configure the particular port to become input or output. So the condition is very simple. If we write 0 at the particular bit position, we are configuring the particular pin to become an output. If we write 1 in TRIS register, we are configuring the particular input, pin to become input. So I'm writing TRIS register on top and port D, and I'm writing the number 0, 1, 2, 3, 4, 5, 6, 7 to show the how each bit corresponds. Now in this case, port D is an input or output. Port D we should configure as input or output. Output, very good. So if we want to configure port D, and which pin that we want to configure as output? All the pins we want to configure as output. So what you should do at TRIS D? 0. When you write 0 at bit number 0 in TRIS D, what it does is it configures bit 0 of port D to become output. That's what it means. So in this case, we're going to write 0 for all the bits so that all the pins in port D will become output. Understand? TRIS D, you only write 0 or 1 to configure. Okay? Any question up to this point? So how do we write that in instruction? Yes. Why output plus LED? When you configure it as an LED, the data direction is from inside to outside. Whatever you write here will be reflected here. If you configure an input, whatever the outer logic will be read into the port. That's why I say data direction register. Now we are configuring it as output. Now how do we write it in terms of instruction?